I'm Jason Johnson. Excited to be here. Glad you all showed up for my talk. I just wanted to mention before we get started that there's a bunch of links to different resources, references, and repositories that you might find interesting. So make sure to check out the link to the slides that I show at the end of the talk. And let's get started. So this is a beginner to intermediate talk, and I figured it'd be good to get started with an introduction to what is Nerves. So Nerves is a set of open source libraries that allow you to do embedded hardware development with Elixir. So basically, you're going to take your Elixir application, add some Nerves to it, and be able to deploy to a bunch of awesome hardware targets like this. So going from left to right, we've got the Raspberry Pi 4, the Raspberry Pi Zero W, the BeagleBone Black, and the Pocket Beagle. This is just to name a few of the devices. So trouble is, there's a lot of different ways to work with Nerves. And if you're a newcomer, it can be hard to figure out where to get started. And if you're not, it still depends on the circumstances of your project. So I decided to make a talk where we would survey all the different workflows for Nerves and look at each one in detail, covering use cases, benefits, and drawbacks. And for our cases, or for our purposes, workflows are anything that helps you develop, debug, or deploy firmware to your Nerves targets. And you might have heard that this is a retro electronics themed talk and thought, what's up with that? Well, I was inspired by the VintageNet library that comes out of the Nerves community. I thought it'd be cool to include some iconic vintage electronics throughout the talk. So just to get us warmed up, here's a few of them. We've got the Polaroid Sun 660, released in 1981. This wasn't the first Polaroid ever released, but this one had a sonar-based autofocus, which made it especially useful. And there's the Commodore 64, the all-time best-selling personal computer in history with over 17 million units sold throughout the 80s and early 90s. And less well-known, the Epson MX80, released in 1980. This is one of the early dot matrix impact printers, you know, the kind that's got like the little holes that are along the side, you tear it off after it's done printing. Well, apparently this thing was so loud that it inspired a post-punk noise rock band to name themselves after it. So Nerves for the win. I'm telling you, now is the best time to get started with Nerves. And you might be wondering, we're in the middle of a chip shortage. Why now? Well, reasons. Some of the most important reasons include a top-of-the-line developer experience, especially when it comes to the ergonomics of embedded hardware development. This backed by incredible documentation that just keeps getting better. And an active open source community that you can find on the Elixir Slack, the forum, or in the monthly meetups. There's also been a lot of open source activity in terms of packages that have been released recently. We've got the Bright Pi Deluxe from SmartRent, support for the Inky impression, and the Unicorn hat. The Nerves core team is also worth mentioning. They've been hard at work releasing a complete overhaul to Nerves. And in the 1.9 release recently, there was a lot of improvements to the documentation thanks to its newest member, Masatoshi. But the biggest reason I would say that we're looking at Nerves for the win is hardware support. And to drive that home, I want to tell a little story about retro video game consoles. So this is the Atari VCS, also known as the Atari 2600. Released in 1977, this was one of the earliest consoles to support ROM cartridges, and it made it really easy for game developers to create their game and deploy it to this console. In fact, it was so popular that developers flooded the market with crappy games and sales dropped off a cliff. And it wasn't until the North American release of the Nintendo Entertainment System back in 1985, where they really focused on quality, that sales picked back up. So what do these two systems have in common? The MOS 6502 chip. It was a popular 8-bit microprocessor that ran at about 1.8 megahertz, and it was really cheap and available back then. And it was used in a lot of different electronics that you might have been aware of: the Apple I, the Apple II, the BBC Micro, and the Commodore 64. But nowadays, Nerves developers can't rely on hardware availability for the win. And that's where Nerves' approach to hardware support really comes in. You can take the same application and deploy it to many different Nerves targets. And the list is growing. Recently, there's been support added for the Grisp V2, the BeagleBone Green Gateway, and the Mango Pi MQ Pro. So now that you got in the Nerves pep talk, what's in store for the actual talk? Well, we've got 11 workflows to cover here, so I'm going to go really fast. But I want to emphasize one in particular, which is host development. And with that, let's turn it up to 11 with a PDP-11. This is Digital Equipment Corporation's PDP-11, released back in 1970. It's a 16-bit mini computer that was the inspiration for the early Intel x86 architecture. So, host development. What are we talking about? How do you do it? Well, this is code that's written on and for the host environment, aka your computer. And this is where most of your Nerves development should be happening. And the reason for that is you want to make sure that you can test the code on the host before you ship it to your targets. And you're going to do that by keeping your application code separate from your hardware code. And you can think about the hardware code as any of the commands that are going to be run directly on the hardware. And you're going to do this with a hardware abstraction layer or a hardware adapter. So what does that look like? Take your typical Nerves project. You've got your dependencies, their configuration, and the application code on top of that. This is where your business logic or business rules about what your application should do live. But the actual doing should live in a number of adapters, like your hardware adapter, your host adapter, and your test adapter. These are all different environments that you want to be reaching out to from your application code for different purposes. So the use cases for host development are literally everywhere. This is where you should be doing most of your development. You should definitely be doing your testing here, and pretty much the only thing you won't be doing is your hardware abstraction layer. That's the code that just runs on the hardware. And of course, you'll be mocking that code on your host, so you're pretty much going to be working on the host all the time. A few resources to drive these points home. There's a talk from a few years ago back at Elixir Days that Amos King gave, Hardware Without Hardware. And then 2 prog books that came out recently that are focused specifically on Nerves, Building a Binary Clock and a Weather Station, from the collective authors Alex Koutmos, Bruce Tate, and Frank Hunleth. So before I move on, I want to mention this guy here. I showed a pic from the cult classic War Games on 2 slides back, and that was a movie where a high school student hacks into NORAD, and it was just a movie. They didn't know what NORAD actually looked like, so they guessed what the computers looked like there. This is what it actually looked like. This is an IBM Sage console, or semi-automatic ground environment, and it was developed by MIT in collaboration with IBM in the 50s and released back in 1963. Really, the idea behind this was they were trying to intercept potential attacks during the Cold War. And it was an early first for a lot of things. It was the first real-time distributed networked application. And I just try and use this as an image along with the others to drive home the point that you want to be testing on the host before you do your deploying. So the benefits of working on the host are plentiful. It's really the best developer experience with the shortest feedback loop. And throughout the talk, I'm going to include a few notes on how long you're looking at in terms of firmware deployment. But this isn't really firmware deployment. This is a short feedback loop of around 5 to 10 seconds just for compiling your code and testing it to see if it works. And again, we're going to get a separation of concerns when we're working with host development and separating out our hardware abstraction layers And we'll also get hardware interoperability. So we'll be able to deploy to different targets, and if there's hardware that's not available all of a sudden, we'll be able to shift our code and quickly deploy to those. It's going to make debugging a lot faster, and your code's going to be easier to reason about. And generally, it'll also simplify your tests. Some of the drawbacks, though, there's going to be more configuration for each of those different adapters. And because of that, you're going to be doing some mocking, and you won't be working on the actual hardware. So things might not work exactly the way you expected when you actually deploy, but they probably will. So moving on to the SD card. SD card is probably where you'll start your Nerves experience. It's like the most primitive way to get your firmware onto your device. And you're going to look for one of these hardware or one of these SD card adapters or an SD card reader like the one shown here. And you'll end up using tools like Mixburn or FWUp, which it uses under the hood, or the Linux command line tool DD, or if you're more into graphical tools, Etcher is a good option. And one more note before I move on, you want to make sure you get a good quality SD card because it might wear out. There's a few different brands that I've heard folks say are pretty good. There's SanDisk, Samsung, and PNY. So maybe look for one of those. So the use cases for SD card are early development. If you're just getting started on a project or you're a newcomer to Nerves, you're probably going to be using your SD card a lot. If you're doing any custom Nerves systems, you're probably going to go through some firmware cycles where you're burning SD cards to get started. And the same thing is true for unsupported hardware or development boards. And then if you're doing any work trying to get a provisioning sequence just right, you're probably going to go through a few cycles with fresh firmware just to make sure that it works the way that you want it to when it comes off the shelf. So the benefits of working with an SD card are that it's going to ensure fresh firmware. And as opposed to some of the other options for getting your firmware on the device, if you've got a really large firmware image, Wi-Fi sometimes isn't quite as fast as doing the SD card shuffle. But it can be a bit cumbersome. It's definitely a shuffle, and it can interrupt your workflow if you're going back and forth between the device and the computer with the SD card. And generally, you're looking at something on the range of 45 seconds to do that whole dance. And if you're doing it a whole lot, you can wear out the SD card. Those little metal tabs on the back can get scratched, and I've also heard that you can wear out the SD card slots on your device, so look out. And I just wanted to look back at this 5 1/4 inch floppy and think about how far we've come getting storage down to a micro SD card. These floppy disks really could only hold a megabyte or two of data. And that's an Apple 5 1/4 inch floppy disk reader from 1986. So moving on to serial cable or FTDI cable, this is probably one of the best ways to work with Nerves. You're going to get direct console access to the device and see output as soon as it boots up. And you're going to do this through a terminal emulator like Screen. So you'll get your cable plugged into your device, and the other end goes into your USB cable or USB port on your laptop, and you fire up Screen, and away you go. So you're probably going to want to look for a cable from this company, FTDI. They're one of the biggest manufacturers of it. And there are 3 different variants of the cable. There's a 6-pin, a 4-pin, and a 3-pin variant. 3-pin's really the minimum that you need. You're going to have transfer, receive, and ground. And there's 2 different voltages to look for. There's a 3.3 and a 5-volt version. You probably want the 3.3 volt version. In the picture here, that's a 6-pin variant. So yeah, the use cases for serial cable are pretty plentiful too, especially good with early development, and if you're a newcomer to Nerves, it's going to be an easy way for you to get started and see output right away. And if you're doing any debugging, firmware debugging or hardware debugging, this is probably your go-to tool. And the image here, this is a 3-pin variant of the FTDI cable. So the benefits of serial cable, of course, you're going to see your console output almost immediately. There's no configuration or networking involved, so it's really easy to get started with. But some of the drawbacks are that it's a wire that you have to tote around, and if you've got a bunch in the closet or in the drawer, it can become a tangle. It's not quite as easy as over-the-air updates. And kind of like USB, when you have to flip it over because it does it doesn't work the first way that you try. The TX and RX pins can be that way too, so it can be kind of confusing when you plug in for the first time and it doesn't work. But you just flip them around and it's okay. And sometimes you can get an impaired console where you're not able to do things like scroll up or copy and paste, but there's a lot of good emulators out there. Just make sure you find one that's got the features you need. And of course, if you don't have one or you're traveling, you just don't have one available, you got to look for other options. Yeah, and before I move on, I want to mention a couple of these images here. This is a RS-232 DB9 crossover cable. It's a standard that was released back in 1962. It was like a predecessor to UART. And this is the type of thing that you would see for debugging where you connect two computers together or a computer to a device like a printer. And down there, that's a Digital Equipment Corporation VT100, released back in 1978. Most terminal emulators today are still based on the VT100. Moving on to HDMI cable. HDMI is pretty similar to serial cable, but in this case, you're going to be plugging into a display, and you're probably going to need to attach a keyboard and mouse to the device. But thankfully, a lot of the Nerves targets support all this stuff out of the box. And many of them have HDMI ports on them. You're going to see either a HDMI micro or a mini port on a lot of these targets. So similar to serial cable, it's very useful in early development and with hardware debugging because you're going to be seeing output early. But one of the especially good uses for HDMI is kiosks. And here I've linked to a kiosk repository that allows you to set up a Nerves kiosk on Raspberry Pi 4s. So the benefits mentioned already, you're going to see console output early. It's not going to be as early as the serial cable because there's a few things that need to boot up first before you can see output. And again, there's really no networking or configuration involved. Although some of the Nerves targets do require a little bit of configuration, but it's not hard. And the drawbacks, again, some people are on, wires are good, and I think wires can be a little bit cumbersome sometimes, so I'm listing it as a drawback. Of course, if you don't have one or you've got the wrong one, it's not always available. So moving on to USB cable, USB is probably the easiest, most convenient way to get started with Nerves. It's the suggested path of least resistance in the Getting Started guide. And to do it, you just plug in the USB. Well, actually before that, you burn some firmware to your SD card, then you plug in your USB cable, and you can connect to it through Nerves SSH over a hostname like nerves.local. So the use cases for it are, it's great if you're a newcomer to Nerves, or if you're starting your project and doing early development, or if there aren't any other options available. USB cables are pretty commonly available, and if you've got one in the drawer, go ahead and use it. The benefits I've mentioned already, they're fast, easy, and convenient to use, and unlike other cables like the serial or the HDMI, you're going to get both power and data in one cable. But you have to be really careful to make sure that you get a cable that supports data. You might waste a lot of time working with a power-only cable and then later realize that you've just used the wrong cable. It happens to the best of us. Yeah, and you're looking at around 25 seconds here to get the firmware uploaded to your device with a USB cable, so it's a pretty quick option. So moving on to Wi-Fi, this isn't exactly vintage electronics. I would call it more of a classic, but you've probably seen these before. This is a Linksys WRT54G, released back in 2002. This is not the Wi-Fi router you want to be using. But yeah, Nerves makes it easy to configure your device to connect to a Wi-Fi network or run a Wi-Fi network. And then you can connect to your Nerves device through Nerves SSH. And the package for which this talk was themed is VintageNet, and it supports lots of different Wi-Fi configurations. So this is the more up-to-date version of the Linksys router I just showed before. This is the EA7500. So maybe look for something like that to use. But the use cases for Wi-Fi, hobby projects, you're probably going to want to connect to your home Wi-Fi and do over-the-air updates that way. If you're doing any prototyping, this is another good option. And if you're doing any commercial deployments, you're probably going to use a wireless access point more similar to this Cisco AeroNet 1552. That's an outdoor long-range access point. So the benefits of Wi-Fi, I would say there's no wires, which I like a lot. And Wi-Fi is commonly available, although I would suggest against connecting your devices to any hotel or cafe Wi-Fi. VintageNet is an incredible tool, and VintageNet Wizard is also really nice. It makes it possible for you to, with zero configuration, get your device up and running with AP that you can connect to and then configure the Wi-Fi. Drawbacks though, even with VintageNet, Wi-Fi can present some confusing situations. If you're dealing with port forwarding or firewall, or you've got intermittent connectivity issues, it can be a real problem. So you're probably wondering if this is a Wi-Fi router here. It's not. This is a Hayes Smart Modem 1200. This is one of the first practical all-in-one 1200-bit modems, and this is the first modem I used to connect to the internet. And with Wi-Fi, this is, again, an average. You're looking at something like 40 seconds from start to finish after you've uploaded the firmware and the device reboots. So moving on, IEX, I think, is a great tool for working with Nerves. It's the interactive shell that we're all familiar with working with Elixir, but Nerves has a special version of it, which as soon as you connect to your device over SSH, it drops you into an IEX session. And you're going to see something like this. This is the Nerves message of the day. And it's got some important information about the device and some helpful commands to get you started. So use cases for IEX are pretty plentiful too. Anytime you're working on the host, you're going to want to be using IEX, especially if you're testing just to see if there's code that's going to work on your device. You can drop it into IEX. And the same is true for remote shell sessions. It's great to be able to access the runtime environment from IEX on a remote device. So pretty much anytime. And I'm curious if anyone recognizes this image here. Yeah, this is from Erling the movie, when Robert Verding is explaining the symbolic trace of their number analyzer. So another throwback there. It's not IEX, but it's in the ballpark. So yeah, the benefits of working with IEX, you get to connect to the runtime environment and work with it, which is a great strength. You'll be able to change like variables, functions, or even entire modules from just copying and pasting them into IEX, which is really useful. There's some great tools that come with Nerves. Ring Logger, which is a great way to be able to see all the logs that have come through before you connected and to tail the logs afterwards. There's the RAM-oops logger, which it's a logger that puts the logs in a special partition that survives reboots. So if you're dealing with something where you're not able to actually get the device to boot, the RAM-oops logger will put those logs somewhere that you can look at them and figure out what's going on later. And then there's Toolshed, which is a tool that brings a lot of the common Linux command line tools into the IEX session. You're going to have things like cd, ls, dmessage, ping, grep. It's a great tool. And I would say if you're doing any work with IEX where you're changing code in memory, be careful because you can kind of code yourself into a corner and find some funny situations. And along with the theme of terminals, this is IBM 3720, released around 1986. This was one of the computers used during the timeshare days to connect to a server like an IBM System 390. So moving on to Hotswap. Hotswap is my favorite way to work with Nerves. It enables fast over-the-air updates of modules right after you compile them in your project. And it does this by passing those compiled modules to an IEX helper called NL that leverages Erlang's remote procedure call to replace the Beam code directly in memory. So I think this is the galaxy brain move of Nerves workflows, and the repository is linked here. So the use cases are firmware development. It's really great if you're working on firmware, or if you're doing any hardware hacking. Maybe don't do the type of hardware hacking seen here. It's also great if you're debugging application startups. So anytime you're working with provisioning sequences, Hotswap can be a great way when you pair it with things like IEX or OTP to update the code in memory and then restart your application supervision tree. So the benefits of working with it are there's no wires. You're going to get your Hotswap over the air. It's going to give you a really tight feedback loop. You're looking at something on the order of like 10 to 15 seconds. And it's relatively easy to set up. There's a little bit of config involved, but the README is pretty good. And like I just mentioned, it's got a great developer experience when paired with OTP. Similar to changing code with IEX, though, if you're working with code, changing it in memory, it can present some confusing situations. A couple other gripes that I have with it. Every time you run Hotswap, it's going to upload all of the modules instead of just the one that changed. So it would be cool if it was a little more granular, but that's OK. It's still really fast. But it doesn't support changes to your config or your deps. So in that case, you're going to have to go through a full upload of your firmware. Moving on to OTP. OTP is that special blend of battle-tested Erlang libraries that we know and love. Talking about like gen servers, processes, supervisors, all that good stuff. So of course, the top use for it is concurrent process management. And some more specific benefits for working with Nerves is it's going to make it easy for you to do tweaking of startup sequences or provisioning. And it's really good for designing supervision trees, because if you've got a hardware situation where you need to see how it boots up and you're going to upload the code or upload modules or update them in memory with IEX, you can use OTP to restart your supervision tree and get moving quickly. And of course, it's great for debugging failure conditions with things like Observer and the Erlang debugger. So the benefits of working with it, you're going to get fault-tolerant, self-healing systems and direct control over process restarts. And mentioned previously, a great developer experience when paired with Hotswap or IEX. And yeah, process inspection and communication is really good too. Drawbacks though, I'm not sure there are any drawbacks to working with OTP. Yeah, and curious if anybody recognizes this device. This is Ericsson's flagship telecom product. This is the AXD 301, released in 1998. This was, apparently, it ran with 1 to 2 million lines of highly complex Erlang code, and it was the first device to achieve the famous 9 nines of availability. Moving on to Livebook. Livebook, if you haven't heard of it, is incredible. It's a live coding notebook that's collaborative, real-time, and allows you to save your notebooks to run later. And Nerves has a special flavor of Livebook that allows you to boot up your Nerves device and host a Livebook. And there's a set of precompiled firmware images that you can download at the repository at this link on the bottom. The official Livebook link is the one above it. So use cases for Livebook, it's great for experimenting with new hardware because you're working directly on the device and you can test code in real time. And it's really good for documentation and creating guides. And because of that, it can be great for onboarding new developers. Similarly, I've heard it's pretty good for recruiting new developers. And if you're doing any kind of demo, like we saw at NervesConf today, NervesConf, it's a great option too. So speaking of notebooks, this is a Grid Compass 1101, released in 1982. This was mostly used by the military and NASA throughout the 80s. But it was inspired by Alan Kay's Dynabook concept. And then on the right there, that's a Apple PowerBook 3400C. It's released in 1997. For a short period of time, this was the fastest laptop in the world. And this was one of the first laptops I ever had. I still have it in the closet. So the benefits of Livebook, it's a live coding journal that runs on Nerves. I can't get over that. That's a really incredible benefit. It's collaborative, it's reproducible, and it's an incredibly tight feedback loop. It's pretty much real time because you're working directly on the device. Some warnings, though, to keep in mind. It's not sandboxed at all, so any code that you run in Livebook can run on the device, including malicious code. But that's somewhat mitigated by the fact that in production, it requires a token, and you can add a password to it. One last word of caution is if you've created a notebook on the device and then you go to add some dependency to the firmware and you burn a fresh SD card image, you might have overwritten your work, so be careful. Nerves Hub, moving on to Nerves Hub, it's a good one. On the surface, it sounds pretty simple. It's an open source firmware update server, but there's so much more to it. Nerves Hub has a ton of services involved, including a CLI tool, a certificate authority server, a front end, an API, and a device update server, all working in tandem together. So it's a pretty complicated system. And To get up and running with it, there's a Terraform script that you can use to install it on AWS. Or if you're really brave, you can run these as separate services on a separate platform. So Nerves Hub primary use case is commercial IoT. Or if you're a consultancy developing a product for commercial IoT, you're probably going to want to use Nerves Hub. Community is also on this list because it's still open source and actively maintained, and you can get it up and running yourself. And just to tie in with a theme here, this is an early ham radio that was pretty popular. It was a ham radio transceiver, the Yaesu FT101, released back in 1971. Kind of put me in mind of Nerves Hub, communicating over the air, through the cloud, back and forth. So the benefits of Nerves Hub, you're going to have over-the-air updates from the cloud, which is really incredible. And you'll be able to manage multiple products and deployments from Nerves Hub. And you'll be able to organize these with tags and search through them. And really, the killer feature, I would say, is you get a remote IEX console to the devices that you manage in Nerves Hub, which is amazing. Some of the drawbacks, though, the community-hosted version of it, which used to be available, was sunset back in March of this year, and it's kind of hard to configure the self-hosted version of it. And on average, you're looking at something like 180 seconds, give or take. This might be wildly different depending on the firmware and your device connections, but it's about an average. So to do a quick recap, I'm not going to cover all of these, but I'll hit the highlights. We've got Nerves Hub for cloud-managed over-the-air updates, Livebook for real-time collaborative hardware hacking, OTP, Hotswap for fast over-the-air module hot swaps, IEX, Wi-Fi, USB cables, HDMI, serial cable, which I would say is one of the top choices, SD card, which is where it all starts, and of course, host development, which is where you should be doing most of your work. There's a couple of workflows that I didn't have time to mention here. These are advanced workflows that I just wanted to touch on. There's a great article by Connor Rigby called Core Dumping Stack Traces in C. So if you're working with C on your device and you need to do any debugging, check out this blog post. There's a couple devices that you might want to look at buying just to get better debugging. There's the Bus Pirate and the SD Sniffer, which you can get from SparkFun. And then on the official Nerves documentation, there's customizing your Nerves system, which is going to show you how to create a custom Nerves system. And with that, you've been great. Here's a Roland 808. Thanks.